Hi, good afternoon. Hello, welcome back. It's the 28th of January, we're 2019. We're talking about the Pythagorean Theorem. Now, we've used the Pythagorean Theorem several times. This is the one that says a squared plus b squared equals c squared. And what I've commented to you about is the importance that c squared always be the hypotenuse. Always, 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 always. Remember that the hypotenuse is directly across from the right angle. And so if you can find where the right angle is, the side that's not touching that angle, that's your hypotenuse. Okay? Now, we can have special numbers that always give us whole number answers on all three of these positions, the A, the B, and the C. And when this happens, they form something called a Pythagorean triple. See if I can spell this correctly today. There it is, a Pythagorean triple. One of the most common Pythagorean triples that are out there, and one that I want you to memorize, is the ratio 3, 4, 5. The largest number in each triple is always going to be the length of the hypotenuse. And so here is your hypotenuse. Okay, that very last number. All right, here's the table. Common Pythagorean triples, so you don't have to get them memorized immediately. Okay, here's how these work. So if we're using the 3, 4, 5. This is one that's related to it. Notice I just took each number and I multiplied it by 2. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. This next one, also in that family, but now I multiplied by 3. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. Okay? And so I can create any number of Pythagorean triples in this family that I want, just by taking this ratio and multiplying it by whatever number I'm feeling like that day. Here's another family, same idea, and another, same idea, and another, same idea. And so we're going to be trying to find values of x in here in some right triangles. Our first task is check to see, can I use a Pythagorean triple? If I can't, do that. It'll save you so much work. If you can't, then we'll use the Pythagorean theorem. A squared plus b squared equals c squared. Okay? All right. Let's look at, which one seems the most confusing? All of them? Maybe 2. Let's look at 2. Okay, if I look at 2, here's my hypotenuse. My largest number is 15. So what I'm going to do is I'm going to look in my common triples for the largest number being 15. I see it in this triple right here. Is one of the legs 9? Yes, that means that without any work, that other leg will be 12. Because this is the Pythagorean triple that we're working with. Would you like to see the Pythagorean theorem worked out on this one to confirm that number? I got a few nods. Okay. So we're going to confirm it with the theorem. My theorem says a squared plus b squared equals c squared. The only one to get in the correct location is going to be c squared. The other two, doesn't matter. Okay? Your choice. All right. Here I go. I'm going to go ahead and substitute in what I know. I selected 9 as A. I don't know what B is yet. My Pythagorean triple says it's going to be 12, but I don't really know, so I'm going to use this variable right here for now. And then I was told that C was 15. 9 squared is 81. 15 squared. 15 squared is, someone help with the calculator. 2, I don't know. All right, let's see if y'all. 225. Okay. Thank you. I'm going to subtract 81 from both sides. And the square root of 144 is 12. Which confirms what I had gotten with the Pythagorean triple. Okay? And number 4. I was requested for number 4. Okay. So number 4, here's my right triangle right down here. So I'm going to ignore the rest of that shape. Here's my hypotenuse. And then one of the sides is A, the other side is B. No one cares which order you pick those in. Okay? My Pythagorean theorem says A squared plus B squared equals C squared. I'm going to fill in what I know. I know A, I know B, but I don't know C, so I'm going to replace it with the variable. Calculators, please help. 16 squared. 625. 625? It's 256? Yeah, 16 squared. Oh, you're doing 25. I need 16 squared. You said it was 256? And 33 squared? 1089. All right, I need to add these two together. I'm afraid I'm going to mess. 1,345? All right. And then if I take the square root of that number, it's probably not going to be a whole number. 36.67. All right, so let's remind you how to simplify this radical, because the directions don't state rounded to the nearest whatever, okay? So what we're looking for is the square root of 1,345. So I need to start like breaking this up into its factors, the things you multiply together to get to that number. So the first thing I'm going to look at is see if it's divisible by 5, which I feel that it is. So someone with a calculator help me. 1345 divided by 5.
269.
269. All right, and now I'd like 269 divisible by something. I'm not sure what it is. I know it's not 2. I'm going to guess divisible by 3. So can someone do 269 divided by 3? Is it a whole number? It's not a whole number. Okay, so it's not divisible by 3. That means it's not divisible by 6, and it's not divisible by 9. Okay? Because 6 is divisible by 3, and 9 is divisible by 3. So if it was divisible by 3, I could probably get 6 and 9 as well. What about, is it divisible? It's not divisible by 4 because it's not an even number. It's not divisible by 5 because it doesn't end in a 5 or a 0. We already ruled out 6. Is it divisible by 7? No. Okay, so it looks like we've gone up a few places already. We're at 7. We know 9 doesn't work because 9 isn't even. We already ruled out, or excuse me, 8. We ruled out 8 because it was even, and this number isn't even. We ruled out 9 because it's not divisible by 3. We rule out 10 because that's not divisible by 5. You know what? At this point, I'm going to be like, I don't think I can get this any smaller. Okay? Because at this point, our numbers are starting to get really big. And when we multiply those big numbers by themselves, we get more bigger numbers than this. So since I couldn't find factors that had those beautiful square roots, I'm going to stop here and be like, I'm done. Okay? And we're just going to say, this is our answer. Okay? Yep. We were just checking. We were going through the can I simplify this? And it didn't look like I could. And that's okay. You go for a little bit until you convince yourself that I don't think I can do this. And then you stop and you move on. Okay? All right. That leaves you 2 others for you to work with. The bottom part of the page says use a Pythagorean triple to find x. So we shouldn't see any Pythagorean theorem work. There should be no ABC, a squared, b squared, c squared. It should all be referenced back up to the triples at the top of the page. So what I'm going to do to keep those triples visible for you is I'm going to take my notes and I'm just going to fold them here. So that way I've got my triples next to my work. Okay? All right. Let's do number 6. So number 6, I don't see a hypotenuse value. So I'm looking at legs with 24 and 45. So looking at here, you're looking at the 2 smaller numbers being 24 and 45. Do I have them? Yes. Where? Here?
Yeah.
There it is. Which means my hypotenuse measures?
51.
Oh, you're done. That's it. It's a shortcut. I matched up. This leg was 24, this leg was 45. And when I looked in my chart, I saw legs 24 and 45. That means that's the hypotenuse. I'm done.
So 515.
I love this question. The question was, what about number 7? Number 7's legs are 28 and 96. And if I look here, I don't have either of those. But recall that this is like the parent of the family, where they all come from. And I can multiply all 3 of these numbers by some other number, and it generates all the rest of these. So really what I'm looking for is, can I turn these 2 into one of these up here by dividing them both by the same number? Well, I'm going to poke at this one, just because I happen to highlight it and for no other reason. Can I get to 28 from 7 with multiplication?
Yes.
Okay, 7 times what? 4? 7 times 4 is 28. Okay. What is, this is supposed to be 24? Okay, so what is 24 times 4? It's 96.
So the other one.
So that means this one has to be 20.
100. That's
Done. The Pythagorean triples are your shortcut to, I don't want to do a lot of work today.
so 5 is 15 then, huh? That's cool.
Mm-hmm. Yeah. If you can recognize the Pythagorean triples, use them. And your work, like up here, if you did number 2, and all you did was write 12, and I didn't state use a Pythagorean triple, and you want to get out of showing all this work, you write for me, please. Pythagorean triple. And what that tells me is not that you just went and found a number and wrote it down, but that you recognize this as one of your triples. And you used the chart to get the answer. And that's fair. Otherwise, we want to see all of this. Okay? So in some way, you're justifying what you've done.
So these you can still use it for grading.
Of course, you can use regular Pythagorean theorem, but on some of them, like, the work just might get tedious and boring and you're done. So if you can recognize a triple, I suggest use the triple. It saves you some time. All right, so let's go to the back. Because the original Pythagorean triple says that if you have a right triangle, then this formula works. But the converse allows you to go from, hey, here's a triangle, and I know nothing about its angles. And with just the measures of the sides, it allows you to classify this as either an acute, all angles less than 90, a right, one angle equal to 90, or an obtuse, one angle bigger than 190. Notice, I know nothing about the side measures. I only know stuff about, wait, let me rewind. I don't know anything about the angle measures. I only know information about the side measures. And yet, using this formula, I get to say something about the angles of the triangle, which is really darn nifty cool. So let's show you how this works. It works with the converse that says, if I have some triangle, and I know that this is true, then I can state it's a right triangle, okay? So if I get a squared plus b squared equals c squared, I can say it's a right triangle. But if, now look at the order. Okay, this one has a squared, b squared, c squared. This order is c squared first, so we're talking about the hypotenuse. If the hypotenuse, or what we think is the hypotenuse, the longest side, if that longest side is less than the sum of those other two sides each squared, then we have an acute triangle, okay? So, biggest side less than the two smaller sides added together, okay? Now, if the length of the longest side is bigger than the other two, then what we're looking at is obtuse. Okay? Equal, longest side equal, right triangle. Longest side smaller, acute. Longest side bigger, obtuse.
So
Okay?
what goes in there?
We're going to have to figure that out. Okay? So that's what we're going to decide. But once we've figured out what symbol goes in there, we can come up to these inequality theorems and just match up to what we have and be like, aha, it's this one. Okay? All right, I'm going to rewrite this top one so it's in the same format as this, okay? So if c squared is equal to a squared plus b squared. Okay? Just so that way it'll look the same for you as all the others. Okay, so your cheat sheet. Longest side equal, right triangle. Longest side less than, acute triangle. Longest side greater than, obtuse triangle. Boom, boom, boom. All right, let's practice. We are going to determine whether each of these form a triangle. And we're going to see if it's acute, obtuse, or right. Now, we had way back when we were first talking about triangles. I need to go back to my old notes because I'm on cold medicine and I don't remember anymore. So back in 5.5, section 5.5, we talked about determining whether something was a triangle or not. We had to add up the measures of sides and check to see that they were equal. Okay? So we had to do this one plus this one and check to see that it was bigger than the other. I'm going to zoom in a little bit. Okay? True or false? That's true. Okay? Then we're going to check the next two. True. And now we're going to check the last two. Okay, so we can say this is a triangle. Now that we know it's a triangle, now we have to state whether it's acute, obtuse, or right. So this is step one. Is a triangle, yes or no? Okay, yes. Now let's check to see if it's right, obtuse, or acute. This will always be the longest side, and then these are the other two sides, and again, no one cares the order. So, is the longest side squared less than, equal to, or greater than the other two sides squared and then added together? I don't know. We're gonna do this. All right. I need 50 squared, please. Someone with a calculator. 2,500. And then I need someone else to give me, 30 squared. 900. And I need someone else to give me 40 squared. 1,600. All right, and someone to add 900 and 1,600. All right. Are they equal? Yes. So, c squared was equal to all of this, which means this is a and that's how this section gets done. Bless you. Yes, sir.
How do you get the square?
How'd I get this squared?
Yes.
Okay, like how did I get the squared numbers like these, or why did I write this? I wrote this because of these theorems. So I'm going to set it up to look like this, and then I'm going to check what the symbol is in here. And depending on what symbol I get tells me the kind of triangle I have. All right, does anyone want to see one more in this section? Okay, then that's all I have for you today. Thank you.